everybody doing here? I thought I said in the talk description, don't come to this talk. And yet, here you are. What's happening? Well, since you're here anyway, let's just get started. My name is Jan. I work for Yoink, a small consultancy in the Netherlands, part of Open Value. You can find me on Twitter. And this is a picture of me wearing a dress suit and a sombrero, which I think sets the tone for this talk. This is what you can expect from me. You may also know me from a little project that I maintain called EqualsVerifier. It's a tool that you can use to test your equals method and your hashCode method in only a single line. And much of the material that I will be presenting to you today actually comes from debugging EqualsVerifier or solving issues with it. So about this talk, I am going to present to you a lot of small accidents, let's call them accidents, and I'm going to show you how you can weaponize them to annoy your coworkers. So if you pay attention now, when you get back to work on Monday, you will be able to annoy the heck out of your coworkers, or even worse. So definitely don't do that, but it's possible. Here are a bunch of things that you should definitely not be messing with. I'm going to show them to you anyway, but we're going to look at some of the Java language features. We're going to look at reflection, annotations, and then a couple of well-known third-party libraries that most projects have on their class path anyway. Every hack that I present, I'm going to give a rating of 1 to 3 emoji. So 1 is the least evil, and 3 you should definitely run away from. So let's dive in and start with the language features. The first hack, the first thing I will demo is the true lambda. So everybody knows since Java 8 we have lambdas, but did you know that if you have a lambda, you can actually call it lambda, which I show here. And this totally works, of course. Oh. See, 1, 2, 3, program runs. So Unicode symbols as identifiers, totally allowed in Java. And just so we're clear, everything I'm showing you today runs on Java 17. In fact, it runs on Java 19. So all of the hacks that I will be showing you today are future-proof. So you don't have to worry about things not working in your environment, because they also work on Java 8 still. And just to prove that, Java version 19. And as a sidebar, I am presenting ways to annoy your coworkers. You can also do that with non-code things like I'm doing here, like using Vim, or running your program using JBang instead of using, a debugger or an IDE, and having a weird color scheme. That really hinders pair programming efforts, which we all can do again now the corona pandemic is over, I guess. So the next hack is about generics. Your mama always told you that you cannot use primitive types as generic type parameters, right? Turns out you can. This program works. So what I have here is an array list of int, not integer, but int. And I can just interact with that like it's a normal array list. And as you can see, it works. The way that this works is that the angle brackets I'm using to declare the array list aren't really array brackets. They are Unicode symbols that look like them. So I have defined here a little class. I called it array list bracket int bracket, and that's the entire name of the thing. If I highlight it, of course, I faked the implementation, but you get the idea, right? You can totally do this. So Unicode symbols, they're hard to type, but they're also hard to read. You can have a bit of fun with them. So I give this a rating of 1 out of 3. Moving on, false is true. So here I have a little Java program. It looks like a unit test. I'm showing the assert equals method here to show to you that nothing fishy is going on in there. But this test actually passes. If I run this program, there is no output, meaning test has passed. But why? If I delete this comment, which is very suspicious, of course, suddenly I get an assertion error. So what's up with this comment? Let's take a closer look. Let's scroll a little bit to the right, a little bit further, maybe a little further. Ah, that settles it. There's nothing here. No, we're not fooled by that, are we? Actually, at the end of the line, I have a Unicode escape sequence followed by if true return. The Unicode escape sequence is the Unicode symbol for a new line. And the Java parser actually reads those Unicode symbols before it actually looks at the code and sees if something is a comment or not. So this is picked up as a real new line, and the if true return is executed. And actually, if I show this warning over here, should have known, right? So if you ever have a flaky test, all you need to do is to fix it is add a little comment, maybe a little spacing so it falls off to the right of the screen. And you have solved your flaky test, which is a nice way to solve them, I think. And therefore, I give it 2 out of 3 emoji. But we can go one step further with this. Here I have a program. It contains a text block, and the text block contains another program. The containing program is really simple. It just prints out hello devox, and that's it. The outer program is a little bit more complicated. It takes the string, maps all of the characters using a converter function, and then puts it in a list, and then outputs that list. The converter function looks like this. For every character that we have, it emits the corresponding Unicode escape sequence. What we can do with this, if we run this, is this program is identical to the one in the text block. So if I output that to a file, let's see that it actually outputs what I expected. Right? So all of the Unicode escape sequences are in here. Let's compile. And let's run. Hello devox. So this is a great way to hide some evil code into your code base. Nobody will be able to read what it says. It's hard to type initially, of course, but nobody will be able to read it. Maven won't flag it, and you can hide anything in there, anything you want. So 2 out of 3, which means that it gets even worse, right? So let's move on to reflection. Here I have a program that does a little reflection magic. we get the value field from the class integer, and we make it accessible. Then we take the 5 object and assign its value field to 4. And then we do a simple for loop. Who wants to guess what's going to happen? I see no hands. Is everybody scared, or is everybody just eating lunch? Okay, well, this was actually a trick question because it fails. Because we have an inaccessible object exception, the module is closed to reflection. Boo. So in Java 9, we got the module system, and this suddenly stopped working. But fortunately, we can work around this. So, as I mentioned, I'm using JBang, and JBang allows me to add JVM parameters. So if I run this again, now it will do something. And if I run it, I get an infinite loop of 4s. So why is that? Well, the JDK, the JVM, will cache the first 127 or so integers. So these are objects that live somewhere cached in the JVM. And if I take the 5 integer, the boxed 5 integer, it will take it out of the cache. So what I did here, when I assigned this value, I assigned the one that is in the cache that is maintained by the JVM. So when I loop over this, note that I am looping over integer, not int. We start with 1, so we start with 0, so it takes 0 from the cache. Then it increments, goes to 1, takes 1 from the cache, 2, 3, 4. And then it comes to 5. It takes the object associated with 5 from the cache, but we just reassigned its value property to 4, so it returns 4. So I is now 4 again. We increment, we go to 5. It takes 5 from the cache, but 5 is 4, so we get 4 again, etc. So this is pretty fun. You can mess up a lot of unit tests if they use magic numbers this way. Just, write a test somewhere that reassigns the value of an int, and all of the tests that run after that one will have the new value and potentially fail. So who thinks this is a bad idea? Ah, now I see hands. And I can imagine why you think this is evil, because int is a thing that we expect to be immutable. So if we handle it in an immutable way, that's unexpected, and that might mess things up. Fortunately, we are quite used to this in the Java ecosystem, right? Because calendars and arrays do the same thing, except here we know about it. So we do defensive copying all over the place. Or we move on to something better like Java time classes or the collections framework. You can have immutable collections, and then you can just pass your values freely and nobody will be able to hack them easily. I say easily because, of course. But if you use JPA entities, you're screwed. There's nothing you can do because they are required to be immutable. Otherwise, it doesn't work. Too bad. So I give this 3 out of 3 because you can do crazy things here. And if you think, well, magic numbers is one thing. Can we do it with strings? We can do even better with strings. So I have a little program here. I declare 2 variables, hello world, hello devox. I print them out. Now I take the string class and take the value property from that string class, make it accessible. Then I take the value from the devox variable, which says hello devox, and then I assign that value to the value field in the world variable. So hello world is now hello devox. Then I print this. We expect, of course, here the output hello devox, and then hello world. Right? Let's take a look. No, because the second one is also hello devox. So what the hell happened here? Didn't I say hello world here? Well, I did, but the JVM does something called interning with strings, which means that if you have a string literal in your code and you repeat it somewhere in the same class, then it will only store the string once and point to it. So when we changed the value of the variable world, we actually changed the string literal that is assigned to it as well. And once we changed that string literal, we did it for the entire class. So this too is a great way to mess up unit tests. I'm giving it 2 out of 3. Next up, who here uses SonarQube in their project, or checkstyle, or something like that? Ever been annoyed by the fact that you have to conform to standards? Like this class over here. It does not conform to naming standards, but I really, really, really want to commit this to my code base. So what do? Well, that's easy. I have a little program here. Again, it contains a text block, which has my dirty class. And then I initialize a compiler. Yes, there is a compiler in your JDK, and you can use it. So I compile my dirty class. I have to give it a name and then the body of the class itself. And I get a class instance. So with this class instance, I can now do reflection to call the methods in there. So I get the doStuff method, make it accessible, and then I invoke it. And that works. So, you know, this is a bit of a roundabout way, but if I really want to avoid check-style rules, this is a way that I can do it. So how does this compiler work? It's actually a lot of code. It's not very complicated, but it is a lot of code. We take the source file, call a compile class method. So this does some initialization at first. Then it takes the compiler and does something with its file manager, I don't know. It tells it where to output the class, and then it compiles it. And when I call the call method over here, the class is compiled, and I now have a class file somewhere in my file system, which I can access with a URL class loader. So when I load that class using the class loader, I have it available and I can use it. Don't worry if you want to try this at home. Everything here is on GitHub. I will share the link at the end of the talk, so you don't have to furiously write along with this. You can just make a picture of the link later. So, of course, this code isn't very nice, because the URL class loader is a closable thing, so you should probably call close on that, which we don't do. You can report compilation errors if the string in the text block is incorrect, which you probably should be doing. And then there's a whole bunch of exceptions that could be thrown that you need to handle normally. But that's not why we're here, right? We're here to mess things up, and handling exceptions is not messing things up. And actually, a fun thing is that this has a real use case. As I mentioned, I maintain EqualsVerifier, and I have been using this in the EqualsVerifier codebase up until very recently, because I wanted to maintain multiple versions of Java, but still be compatible with Java 7. So every time a new version of Java came out, starting with 8, I made a unit test that uses this. So every test first has a little check. Are we actually on the correct JVM or not? If not, then we return and the test obviously succeeds. If we are on the correct JVM, then we continue. And here is a long string with a Java 8 program. See, it contains a lambda. So I can compile that with the code that I showed you before. And then I can just pass it to EqualsVerifier, and that works. And surprisingly, I never had any problems with this. Not once. So very effective and a good way, again, to hide nasty things. So I'm giving this 3 out of 3. So annotations. Who here has heard of Lombok? Almost everybody. So Lombok is a thing. It is a bit controversial because it uses annotations to make the compiler do things that it would normally not do. So there are people who don't like that because the code that you see is not the code that is run, right? So some people want to avoid this in their code. What if I tell you that there is something that is even worse than this? Because Lombok does this at compile time, right? So if the compilation is done, you don't even need the Lombok dependency anymore. It goes out of your way. It does nothing anymore. So once the compilation is done, it can do no more damage. There are tools that do the same thing, but they do it at runtime. Are they also evil? I hear some people saying yes. I like that. I like that. I like that a lot. Okay. But still, we use this stuff every day, so it's boring, and I'm not going to say anything more about it. Let's talk about external libraries. Who here has heard of obgenesis? I think I see only one hand. Wow. So obgenesis is a library that is used mainly by mocking frameworks. So you probably have it on your class path if you do mocking. You can use it to instantiate objects without calling the constructor. So let's see how that works. Okay, so I have a class. Constructor throws an exception. ToString returns a string. I want to print this string, but obviously I can't call the constructor. So what do? I make an obgenesis instance, and then I use that to create an instance of my class, and then I can use it. So if I run this, it works. No exception. So this is pretty boring, right? You can't do a lot of damage with this directly. But who has read Effective Java? I see some hands, not a lot. You should really read this book. It's very good, except it got one thing wrong, because it says that an enum provides an ironclad guarantee against reflection attacks, which is why an enum is a great way to create a singleton, because a singleton, as we know, can only exist once. You can only have one instance of a singleton, otherwise it wouldn't be a singleton. So an enum is a handy way to define that. But does it work? Let's take a look. Here I have a class. Again, I need to add my add opens thingy. I also define the dependency. And here is my singleton. It has one element. It's called instance. Cool. Here I make a copy of that, and then I print both of them out to show you that they are the same. And then I do equals and print the result of that. What do you think, true or false? Anybody thinks true? Of course, nobody thinks that. You've been paying attention. So if I run this, of course, they are not the same. How does that work? Well, I use obgenesis to create a new instance, and that's already where things go wrong, of course. But let's finish it up, make it neat and tidy. Here I can take the enum class. Every enum implements the enum class, and take the declared field ordinal, and I give it the same value that was in the original instance. Every enum also has a name property, so I copy that one as well, and now they are the same. And that's it. That's really all there is to it. So I wouldn't even call this attack very sophisticated. I don't know. I give this 2 out of 3. Because with some other libraries, we can take it a step further. Who has heard of Byte? Some hands. So for those of you who don't know it, Byte is a library that you can use to generate byte code at runtime and play around with that. Byte agent is a tool that helps dealing with, obviously, with agents. And agents are a thing that has been with Java for a long time. You can have a little bit of code that is an agent, and you can attach that code to a running Java process. And then the code will be executed inside of that running Java process. So that sounds a bit scary. But actually, there's lots of use cases for that, and they are very legitimate. You can think, for example, about debuggers. They use agents, or profilers, those kinds of things. But of course, we're not going to do something legitimate with it. So in France, you can buy decks of cards. They are called tarot cards. They are not for predicting the future, they're just for playing games. But the fun thing about them is that they contain all of the cards that we know, and then a couple more. In fact, they have an entire new suit. So we are used to the hearts and the clubs and the spades. And the tarot cards have an extra suit called the trumps. And they go from 1 all the way up to 21. So how would that look in a program? I have a suit, enum, that contains all of the suits that we know. And in my program, I'm going to first print them out to show that there is no sleight of hand. Then I will shuffle them, and then I will add an enum constant at runtime. And I will print them out again. So take a moment to see that the for loops are identical, because they are. So for my next card trick, I'm going to add something. So first it prints out the 4 suits, then it prints shuffle. You may have noticed it takes a little while. This is an expensive operation. And now we have an extra suit in our enum. And remember, we can just do this at runtime. Isn't that cool? So how does that work? Well, it takes a bit of code, as you can see, but I'll walk you through it. We start with an obgenesis instance. And the first thing we do is from the enum type, so the class called suit in this case, we take the declared method values, which is a method that contains that returns an array containing all of the elements. We invoke it, and now we have the original array containing all of the enum constants. And we save also its length. Next up, we create a new instance of the enum, This is the same as in the previous example, so nothing new here. Here we do some array juggling. We create a new array with an extra element. So we copy the original array and then we add our new value at the end. And then finally, we install a ByteBuddy agent. We do some initialization. We redefine the type suit. And we take the method called values, we intercept it, and make it return something else, specifically the thing that's in this object. Then we make it and we load it with a class loader and we're done. And that's it. Now you can add an enum constant. And all you have to do is have ByteBuddy on the class path. And again, this is a very common library. It's used in mocking frameworks, but also in things like Hibernate and all kinds of other frameworks that do bytecode, funny stuff. So this is really extreme, and I give it 3 out of 3. And a thumbs up from Mr. Trump, because we were speaking of Trumps. But there's more. For my final trick, I will do something really weird. So we start with a class called victim. We're going to attack this one. The victim class doesn't do anything really special. It prints out the current process ID because we need that for what comes next. And then it just prints out the current time every second or so. Then we go to the attack class. That's also not very exciting. It takes 2 arguments from the command line, specifically the location of the jar file that we want to attach to the running process. That's the jar file containing the agent. And it also needs to know the process ID that we want to attach to. And then we take ByteBuddy and we let it do its thing. Okay, so what does my jar file look like? This is a bit more complicated. It has an agent main method, which is a thing that it's a special method, just like the main method in regular programs, public static void main. Agent main is similar. It's been around since, I think, Java 1.0 or 1.1 or something. And once it attaches to a running process, the agent main method is called and you can do things. So the first thing we do is we print something. I'm going to skip this bit for now. Next up, we are building an agent again. We do some initialization here. And then we take the type called Java lang system and transform it using a transformer. And then we install it in the process. So what is this transformer? That's this one over here. It is a lambda. And of course, I'm nothing if not consistent. I've called it lambda. And what it does is it takes the method called currentTime millis and intercepts it and makes it return a value of my choosing. So how does that look? So here are my files. Let's first run the victim. And we copy paste the process ID. Oh, of course, we also have to compile our jar file. As you can see, it's called target/payloadx. So I can call that here. I paste in the process ID, and then I run it. And you see, let's install some malicious code, and now the time is always 1337. This is my rating. So let's wrap up. The first time I gave this talk, somebody in the audience said, well, those are all pretty cool hacks, but of course you're here to create awareness about this, right? So that we know what we have to be careful for. Actually, that was not the case. I just wanted to show some cool hacks, but he did have a point. So let's see what we can do to protect ourselves against these kinds of attacks. So for the Unicode tricks at the beginning, it's pretty easy. You just have to set up check style and sonar cube or something similar. But of course, we have all been paying attention and we know how to avoid that. So what can we do about it? Well, first thing we could do is install a security manager. So let's try that. We go back to our intern class. As we remember, there's some reflection strangeness going on here. So we install the security manager. Oh, oops. We install the security manager over here. And if we now run the program, we get some warnings, but finally it says Java security access control exception, access denied. You are doing reflection, please stop, is what it says. But what about these warnings? It says security manager will be removed in a future release. Wait, and that's true. That's true. I'm using Java 19 and I actually hid something in here. I added this parameter, security manager allow, because in Java 18, the default behavior is that it is no longer allowed to use a security manager. So if I now try to run it without that parameter, it fails in many ugly ways. So the warnings are a bit more verbose, and finally it says unsupported operation exception because the security manager is deprecated. So using a security manager is problematic because, of course, tools like Spring use reflection all the time, so you have to configure it really carefully, otherwise it won't work. And of course, in Java 17 it got deprecated, and in Java 18 even more so. It's going away. So another thing you can do is modularize your code, but of course, who wants to do that? The best thing you can do is just be careful and know who has the keys to the castle. So to wrap up, do try this at home. I say at home, not at work, at home. Clear? Okay, clear. That's it. Is there time for questions? 2 minutes. Any questions? There's a question over there.
Have you used that in production-like code, like EqualsVerifier or stuff like that? Any of the trick?
Have I used any of this? Well, as I mentioned, in EqualsVerifier, I did do the compiler thing. But no, I have not used this in practice. Other questions?
Not officially.
Not officially. Yeah, of course, I'm not going to say this is all recorded, so I'm not going to say anything that might incriminate me. Any other questions?
The timestamp 1337.
Yes. What's with the timestamp 1337? Well, it's lead, right? It's lead speak. It's just, I needed a value. Other questions? Okay, well, thank you very much.